My name's Andy Trice. I'm a developer advocate for IBM for the mobile first platform. And today I want to talk about building better native apps using mobile first. Now, before I dig into what mobile first is and go into all the details, possibly to some excruciating pain in the detail, want to see what are you guys doing? Where are you? So, how many people are native developers? Okay, iOS, Android. Okay, yeah, both. One hand there. Okay, how many people are developing hybrid apps like Cordova, PhoneGap, something like that? Okay. Anybody already familiar with mobile first platform? Just a little bit. What's that? Is it the same as no. So, anybody already using IBM Worklight? Okay. Are they the same? Yeah, Worklight is now mobile first, but there's a lot more on top of what Worklight used to be able to do. Well, I say used to be able to do. What Worklight can do, mobile first platform offers you even more. So, let's go ahead and get started. And also, before I jump too far into this, I want to say, we've got an intimate audience here. If you have questions, feel free to raise your hand, ask me. My role as a developer advocate is to, inform you guys, make sure that you're getting the most out of this. But also, if there's things that you'd like to see in the platform, things that would really help you solve a critical business problem, let me know, because it's my role to also take that back to our product management and make sure that we're delivering something that you guys need, that you guys want, and that you guys can use. So, without further ado, when you're building an application, you enter an iterative cycle. First thing we do is we build an app, then we release it, put it out in the App Store, it goes out into the wild. Then you make some enhancements, you build upon this, we're back over here, we're building again, we're making better things in the app, hopefully everything's better, we're releasing it again, and it is this iterative cycle of continuously improving, delivering, and you're always building on top of a solution that, your base solution. So if you are adding features, adding value, then you're making this better. Where this gets slightly more challenging is that, there might be a bug in there. Who, by show of hands, has ever written bug-free code? Yeah, I'm full of shit. Excuse my language, I forgot this is being recorded. Yeah, bugs happen. And often, especially with mobile apps that are running on a client device that you might have a million apps out in the field, there might be more bugs than you think happening, and often you're in the case that you don't necessarily know that this is what's happening. It's really important to have tools that help you collect information and have kind of an overview of the status of your app when it's live, when it's out in the wild. Everything from the development cycle, so as you're building app, all the way out through production, through the entire life cycle, through this iterative process. So mobile first platform offers you a couple things. First of all, when you're building the app, it gives you the tools that you need to be able to get data into the app. So if you need to expose data from an existing data store, whether you want to consume things through, let's say, a web service, whether it's a RESTful service, a SOAP-based service, or some other kind of service, and you need to serialize it in a format that's easily consumed on the mobile device, we give you tools to do that. We also give you tools to have secure storage, so you can secure your data on the device so that if your device is compromised, your device is encrypted, your storage is encrypted, your information is still safe. I think 4 out of the top 5 banks in the world leverage mobile first platform in some fashion because of, it's very powerful, very secure. We also give you the ability to capture logging, so not only while you're developing app, but once you push that into production. And this kind of leads me into the next slide. I need one of those clickers so I don't have to constantly walk back and forth. And the next part is, once your app goes out into the wild, it's very, very, very important, as I mentioned earlier, to know what's happening within your app. By a show of hands, anyone who's put an app out into production, and you have a live app, it's out in the App Store, whether it's Enterprise App Store, Commercial App Store, how many of you know exactly what's happening with that app at any point in time? Okay, that's my point. Nobody raised their hand. The mobile first platform gives you tools out of the box that give you insight into what's happening within your app, whether you're trying to track down an issue or whether you are trying to just understand what's the load on my server, how many services are being called, what services are being called, how many devices are being invoked, which devices are consuming the APIs, which operating system variants of those devices, and so forth. So mobile first platform, ta-da. IBM Mobile First has the tools that you need to deliver in both of these scenarios, when you're developing, and then also once you've deployed, once you're live, once you're out in production. Mobile first platform basically consists of two different parts. And I say basically because there's more to it than just this, but I'm trying to put it in as simple terms as possible. There's a back-end aspect of it. This is on a nice, shiny IBM Z series mainframe. You could have an on-premise solution, or you could leverage mobile first on IBM Bluemix. IBM Bluemix is our cloud services platform. I'm going to try and cover both of these in as much detail as possible as I can within basically an hour. So we've got the server aspect, and then we've got the client-side aspect. The client side is the API that you use to gather, but expose data on the client side, collect, and also collect operational analytics, and you use that in your actual development pieces of it. So on the server, we're exposing data, we're collecting data. On the client, we're, again, consuming data, but we're also collecting information about what's happening within your app once it goes out in the wild. So I mentioned earlier, when you're developing, you need to access and store data within your app. And I promise I'm almost done with PowerPoint. I hate PowerPoint. Who else hates PowerPoint? OK, yeah. Got one guy who's honest. Come on, the rest of you. So you need to consume data. You need to expose that data into your app. You need to be able to monitor how much data is being consumed, how long is it taking, all these different services. And we need to make sure that it's secure, so we can secure everything that's on the device. We also, once you put an app out into production, and once you put out more than one app, actually, anyone by a show of hands have an app, regardless of whichever platform, that you have multiple versions of it out in the wild, and it's never been a headache? OK. I don't know if you guys haven't put multiple versions out, or if you've never had a headache with it. But basically, think of a scenario. You have an app. You put it out in the wild, and let's say it's a really big mass market thing. You've got 1 million devices that are out there using it. You put out a new version, only 500,000 people download it and update the app. Then you put out another version, and let's say you have 400,000 people using it. So you end up having different people with different versions of your application. Using mobile first platform, we can see who's using which version of the application. We can send messages to particular versions. So we can say, if you're on version 1.0, you know what, we're going to shut you down entirely. We don't want you using it. We're going to cut off access, and we're going to force you to upgrade. If you're on 1.1, we could say, we're going to let you use it, but we're going to display a message not forcing you, but telling you, hey, this is being deprecated, so you might want to think about upgrading. And if you're on version, 1.0, 1.1, 1.2, then you know what, everything's golden. We don't have to worry about it. Until we release the next version, then we can start changing what's allowed, what's not allowed. And let me actually back up for a second. I forgot to mention, when we're talking about the client-side SDK, right now I'm talking about building better native apps, in particular for iOS. We do have a hybrid SDK, so if you're developing hybrid applications, it's based upon Apache Cordova. We have native for iOS, we have native for Android, we support Xamarin, we support Windows Phone. So there's a lot of platforms, if you're really opinionated for or against something, you know what? You can use whatever platform you want. We support all major platforms. And you can expose this functionality regardless of what the platform option is. Let me jump back over here. OK, jumped too far ahead. So let's talk about engagement and notifications and how you're engaging with the users of your applications. We have an API that makes push notifications very, very easy. So if you want to send out notifications to all devices that are consuming your application, if you want to send out to a particular platform, a specific device, or if you want to create tags. Tags can be a logical organization of devices. When you're in the app, you can subscribe to a specific tag, and then you can send out push notifications to each one of those devices that have subscribed to that tag. We have the ability to do that. We also have geographic-based notifications. And the mobile-first platform gives you the tools to interact with your users, with the end users of your apps using the push notification paradigm. And also, as I mentioned earlier, we give you the tools to monitor your application throughout the entire lifecycle. And when I say monitor throughout the entire application lifecycle, I talk about remote collection of logs from mobile devices, as well as operational analytics, so you can see what apps are being used, which API endpoints are being used, which services are being used, and insight into the performance of all of those. Now, when I talk about remote logging, so we're remotely collecting logs from the client applications, I'm talking about, let's say you have devices out in the field and you're trying to track down an issue on certain classes of devices, you'd be able to capture pretty much all the information coming from the device. Just like, everyone familiar with log4j for the server, for Java? Okay. Anyone not familiar with log4j? Okay, a couple people. So, log4j is basically a logging framework that you would use building a Java application server, like on the back end. And it allows you to define messages that are coming out, whether they're at an info level, a debug level, an error level, fatal level, so that you can see in your server logs, based upon your configuration, only show me everything that's error and above, or if you want to show me all debug information, everything like that. That may not have been the best explanation, but that's all you're getting right now. With the logging tools inside of Mobile First Foundation, you have essentially the same kind of thing, but it's logging from the clients and we're collecting it on the server. So if you have all your debug messages, you want to see, I'm entering module 1 within my code, and I'm making a request to whatever endpoint, and I'm requesting data for foo, whatever it might be. If you're collecting all that debug information, we can set it up so you can collect all that information from all of your clients that are out in the field. Now, if you have 1 million devices, again, that could be a massive amount of information. So we can configure based upon the operating system, whether it's the platform, the operating system version, the specific kind of device, we can specify the granularity of how much information you want to capture. But let's say you're hitting an error that only happens on a particular, let's say an iPhone 5 running iOS 7.1. We can say on all phones that are all iPhone 5s that are running iOS 7.1, give us all the information, and we can collect all the logs. We can actually see all logs for a particular device. So if we're encountering that error scenario, we can trace through the entire life cycle of the app, or not necessarily life cycle is not the right word. We can trace through the entire output of the app and see exactly what was happening, and go and try. As a developer, you can use that information to try and recreate the error scenario, and eventually, that helps you develop a better application. So I told you I don't like PowerPoint. So that's it for PowerPoint. Actually, it's not even PowerPoint, it's Keynote. But now let's talk about building applications with the mobile first platform. So the first thing I want to show you is building applications with the mobile first platform on Bluemix. Bluemix being IBM's cloud services platform. So I'm going to go to my dashboard here. And while this comes up, I'm doing this live on a live server. Yes, it's my account, which is like a developer account, but I'm doing it live on an extremely fast network, so please bear with me. And hopefully it doesn't keep kicking me out. The last time I did a presentation like this and tried to do everything live, the network kept going down and it kicked me out like every 30 seconds. And it was fun. A lot of fun. So, okay. When you're on Bluemix, let me take a step back from mobile first for a second. Let's talk about Bluemix. Bluemix is the cloud services platform that it's essentially a composable cloud infrastructure. It allows you can create apps and you can add or remove services as you need them. So if you want to stand up a Node.js instance, you can do that. If you want to add the mobile first, which is the mobile offerings on Bluemix on top of it, you can do that. If you want to add IBM Watson, which is a cognitive computing platform, you can do that. If you want to, I don't know, there's a whole catalog that I think it's got like 20 or 30 different options, like composable options that you can pull into your applications as you need them. You can pull in whatever you need. You can also, new features, you can add, you can have Docker containers, you can have VMs. So, it's you have the option of having basically like that VM all the way to that composable platform as a service infrastructure. When I want to create an app, so here's my dashboard when I come in. You can see what apps I already have here. I'm going to go ahead and create a new app. And this is going to basically give us everything that we need to create a new app that's powered by the mobile-first platform. We can say the app, what kind of app are you creating? Web app or a mobile app? Web app would be based on Node.js. Mobile is going to give us all the mobile pieces. So I select mobile. We come in here. Can you guys see that, by the way, or is that too small?
No, it's good.
It's good? OK. When we're in here, what platform do you want to use? Do you want mobile or you want iOS 8? Mobile would include iOS, Android, hybrid. And this, again, I'm talking about the Bluemix, the cloud-hosted option for mobile first. So we support this option, iOS, Android, and hybrid. We also have another one for iOS 8, which is technically still in beta, but the samples I'm about to show you are built on the iOS 8 option. If you want to do multi-platform, you wanted to support Android and iOS. And I didn't mention this earlier, I don't think, that if you're doing, let's say, push notifications, and you want to do push notifications on multiple platforms, so if you want iOS and Android, you can have one API for managing push notifications on both platforms by choosing this option right here. But I'm going to go ahead and jump into the iOS 8 option. So I would go in here to iOS 8 and say continue. It's going to ask me to name it. I can name my app. And once you walk through this process, let me jump back over to the dashboard and jump into the app I've already created. We're going to come in here, and this is going to be created for you. So this is your app. Based upon the boilerplate, I haven't added any additional services, anything else in it. What we're going to get, up top, you can see we have the SDK for Node.js. So you get a Node.js instance, and you can pull down the code. You can customize it. It comes pre-built with Express.js. So if you're familiar with Express.js for Node.js, which is a framework for building apps, you can do whatever you normally do in Node.js to build whatever kind of app you want. If you want to expose more services, custom workflow, whatever, you can do that in Node.js. You get heavy load, you want to scale up. There's the drop down right here where right now I've got one server instance with 512 megs of RAM. Scale it up whatever you need. It is, a cloud service. You can scale it up, and yes, the more you ramp up, the more load you put on it, the more resources you're consuming. It might cost you a little bit more, but you scale it based upon your need, whatever your application is doing. Yeah.
Is there any way to have some sort of script system where if your usage or demands are monitored and they're going up, it automatically dumps your instances in your memory?
I believe so. I'm not the DevOps guy, so I can't tell you exactly how to do that, but I believe so. I'm more on the mobile side of things. I believe so. But yeah, you can scale it up however you need it. So we've got the Node.js instance. We've got advanced mobile access, which is a component specifically for mobile applications. If you were doing, I told you there's two options. There's iOS 8, and then there's the multi-platform options. When I had the two boxes that were up here side by side, advanced mobile access is the iOS 8 version. That comes with iOS 8 push also. There's also the regular mobile access, which is they're almost the same. There's a couple feature differences, but they're roughly the same kind of feature. So what you're seeing here, there's going to be something similar available for other platforms. So we have advanced mobile access. I'll show you more on that in a second. We have a Cloudant NoSQL database, which is a boilerplate part of this boilerplate template, which that gives you NoSQL database. So if you're developing a mobile app and you need to turn things around very quickly, you need to be very fast. Gives you the advantage of having that non-structured data store. I don't want to get into a debate of NoSQL versus relational because we could go wildly out of control with that. But we have the option, or not. You have the option, if you wanted to put a relational database in here, Bluemix services do have a relational database option, but the default mobile template comes with the Cloudant NoSQL database. And it comes with the push service. So this is for managing push notifications in your app. Now, when you want to connect your app, actually, before I do anything else, let's look at an app that I've got here. And I'm going to show you just the app, because it's a really simple app, and then I'm going to talk about how we're empowering this app using mobile first. So I'll go ahead and launch it. You can see we've got insurance dashboard. It's beautiful. Not really. And the network allowed us to say, OK, everything worked right here. So this is my quote-unquote insurance dashboard. I'm not in the insurance industry, so I totally made this up, the workflow. But what I wanted to show you is just that we have an app. We're loading data. So we've got multiple views that are happening here. So if I tap on one of these on the left side, we can go into the view. We can see details. If I tap on one of the main options that we have here, you can see we've got a detail view. So it's more like just kind of like a master detail flow for the data. It's not industry specific because I'm not in insurance, so if it's wrong, so be it. But it does have all the key points that you would, key things that you would encounter if you are building an application. We're loading data from a server. I've got push notifications in, so I'm consuming push notifications. I've got remote logging. I've got analytics. So this is the app. It's very, very simple. And you can see, if you see the characters, they're all mostly from Disney movies. I have kids. We watch a lot of Disney. So now let's jump over to Xcode and make sure I'm looking at the right one. Yes, I am here. So the first thing that you need to do, if you're building an app, is you need to connect to the mobile first server, which is running in Bluemix, which is the Node.js server. When you set up your app, the mobile first on Bluemix is going to provide you a set of instructions where you can use a framework called Cocoapods to manage all your dependencies for you. Is anybody familiar with Cocoapods? Okay, I see a couple people nodding their heads. It's basically just a dependency management framework. You set up your configuration file, it pulls down everything you need, it formats your project for you, and then you just start building. You don't have to worry about configuration. So once you set up your project and you've got everything configured, in order to connect to the mobile first backend, all that you have to do is create an instance of this IMF client and give it a route to your backend, which is going to be the URL of your Bluemix server. And you get that when you create the app. If I jump back over to Bluemix, I'll show you. So you need to initialize with the URL of your server and also your application GUID. Now this is being recorded, so everyone's going to know my application GUID. I'm going to see a lot of load on this server, right? You guys are going to hack my system. I know, bad jokes. I'm the king of bad jokes. So right here, you'll notice that when my app was created, so this is on my Bluemix dashboard, I can see this is the URL for my app, so for my application server. You scale it up, it's still going to be the same URL. I can go ahead and we'll open this in a new tab. And you can see that, hello from the back end. This is based upon my application, which right here. This is in app.js, which is my main entry point into the Node.js backend. And I mentioned earlier, this is built on top of Express.js. So anything that you're doing in Node.js, you're writing in JavaScript, you're building your application, it's going to be accessible in that server, regardless of whether or not you're consuming it within your actual mobile application. Just to kind of give you an example, like here, I created a new URL endpoint that's just called my service. So if I jump back to the browser and we put my service on there, you can see this is my response. I mean, it's really, really simple, but I just wanted to show you right here where it says this is my response, that you can do pretty much anything on that server that you can do within Node.js. If you want to pull in other libraries, if you want to use NPM and take advantage of different frameworks, whatever it might be, you can take advantage of that and expose it within your application. So back over here, I showed you the first thing you have to do is connect using the IMF client class. And let's say you want to set up logging. Actually, I haven't shown you the logging yet. I just showed you the app. But we'll take a look at how you set up logging. It's very, very simple. And then I'm going to show you what we're able to capture, what you can see on the back end, so you have insight into what's happening within the application. So right here, IMF logger, capture uncalled exceptions. This is setting up so anytime the app crashes, we're capturing that. It's one line of code. You're capturing every crash. You can use that to report on what's happening within your application in the future. We can set our logging level. So right now I'm setting it log level debug. And so I'm going to capture all the debug messages coming off my app. And then you just need to create a logger instance. And this using IMF logger, create logger for name. I'm going to call it app delegate just because I'm in the app delegate class. You can give these whatever kind of text string based name you want. But I find it generally good practice to name it the same thing as the class that you're actually editing in. So that way, when you're going through the logs later, you can very quickly see, where is this information coming from. And then if you want to send a message, we just have logger, log debug with messages, and I'm just passing in, this is a log message from app launch. So I'm just sending a message to the back end. And if I jump back here, let's see, what else am I doing? OK, that's all push notification. We won't get to that yet. If I jump back to my app, so when I launched it, actually, let me turn on logging here. In our console, we can see down here, analytics data successfully sent to the server. So that means any analytics data, any logging, whatever it might be, has been sent to the server. When you're developing the application, you're running it from Xcode. Anything that you output through that logging class is going to be dropped out here. You're going to see it in the console, just like if you were using nslog as you're writing your native app. So it doesn't change the developer experience. Where it becomes even more powerful is when we jump over to the server. And I'm back here, and I'm going to click on Advanced Mobile Access and pray that the network gods are nice to me. And in here, so Advanced Mobile Access, actually, I'm jumping ahead of myself. We'll get into logging in a moment. Advanced Mobile Access is where you can see what your route is, what your unique ID is for your app. You can also add the versioning to your app and authentication. So we can tie into any OAuth provider. So you can have, let me just go ahead and we'll add another version of the app. Version 1.0 of my app, which is what's running right now, is not authenticated. I'm not requiring any kind of authentication. But if I did add authentication, so I'm going to add 1.1. When you try and access the app, we're going to add new authentication. Out of the box, with literally one line of code, we can add Facebook or Google OAuth, or we can add a custom OAuth provider. So if you already have an identity management solution that offers OAuth for authenticating your users, then we can tie into that, and you don't have to create like a login mechanism and everything inside the app. We'll handle that for you. It makes developing the apps very, very simple. So once you have that, I jump back too far. Come on, network. When you connect to your app, so just that one line of code where I said IMF client, register application, I think is what it was. I don't remember exactly. If you had authentication, that's when it would prompt you to log into the app. And then once you're logged into the app, then it's going to allow you to proceed. If you weren't logged in, it wouldn't let you in. And once we're actually in the app, let me go ahead and set our, OK, we're on the last 30 days. Now, there's not going to be a lot of data here in the operational analytics because this is just my test client. I've been using this sporadically over the last couple of weeks. This is the last 30 days. You can see my data points. We're going to be able to see how many active devices are there. So if you have 10,000, 100,000 devices in the wild, you're going to be able to see, per day, per hour, whatever it is, how many devices are actively live on the system. We're going to be able to see what services are currently being used. If we jump into usage, wait for it to catch up, we can see, how many application views are there that are happening, how many new users. Again, I mentioned there's not much data on this because it's literally just been me using this service. But if we had a lot more data, we'd be able to see that. We'll be able to see, network round trip time. How long are our network requests taking? How many network requests are there? We can drill in and see information about every service request that's being made through the application. We can come in to see devices. We can see how many active devices are there. And again, yeah. There's not a lot of data, but it gives you a very good snapshot of if you did have a lot of usage on the system, you'd be able to see a lot of information like how many people are actively using it, how many new devices are there. We can see authentications, how many user validations have there been, how many resource validations if you're accessing protected resources. So it gives you a lot of operational analytics into the snapshot of what's the current load on your system, like what services are being called, how many devices are consuming it, what kinds of devices. But it also gives you, I mentioned earlier, the logging. So let's say if we want to see all crashes that are happening within the app, we can come in here and see, OK, we've got an uncalled exception. And this was actually when from a previous version of the app that I had, where I had Facebook authentication, and I didn't have it configured correctly. But you can see, I can see the crash, I can see what happened, I can see that it happened in particular on iOS 8.1, and I could go in, drill down, and see lots of information about it, and I can also get the entire logs for this device. So I could say, give me the entire logs over the last 30 days. It's going to pull down. We'll open it, and we can see there's far more data than I care to go through right now. But if you're in a situation where you are trying to track down issues that are happening within your app, and you part of this iterative process of constantly improving the application, this is incredibly helpful because it gives you the tools that you need to be able to track down those errors, track down that information. So in a nutshell, that's what's available as part of Advanced Mobile Access.
Is there some sort of API so that maybe our business intelligence reporting guys can come in and pull this information and generate reports off of that?
I've never tried that. I would expect that yes, you would be able to. I don't know off the top of my head how you do that, but it's something that. If you want, we can sync afterwards, and I can get information, and I can look into it and get more information. But yeah. So we've talked about registering the client, really simple, 2 lines of code. User authentication. If you want to authenticate your user, you add your auth to your version, which I didn't hit OK, so it didn't get added. But you do be able to see which clients are supported here, and it's like 1 line of code to actually add your authentication. And then we're able to have those operational analytics, so on devices, on usage, on how many are currently hitting the system, all of that out of the box without any additional code. So from a development perspective, it saves you a lot of time because we don't have to write all those services. We don't have to do all that. You don't have to do that yourself. And also, it took 30 seconds to walk through the process from the dashboard of creating the app. So in 30 seconds, we've set up the entire infrastructure for everything that I've shown so far. Plus more, and we're going to see the more in just a second. OK, we're back on our dashboard. And the next thing I want to show you is the Cloudant NoSQL database. Now, database is database. It's a place where you put information when you get information. Not going to drone on about SQL versus NoSQL, relational, non-relational, but I want to show you how easy it is to get data in and out of the app. So being a NoSQL database, this has nothing to do with whether or not it's NoSQL database, but the Cloudant database that you get as part of the application boilerplate is accessible from the client side. So you have a client-side SDK, so you can create new database instances, you can add data to it, you can populate it, you can do whatever you want, all without actually having to touch a single line of server-side code. You can access all of this information from the client-side SDK. You can serialize objects as generic objects, so in Objective-C. Actually, let me back up for just 1 second. Also, in the description for this session, I would talk about Objective-C and Swift. I'm just showing code in Objective-C just because I figured it's kind of redundant to show you one thing in Objective-C and show you the same thing in Swift. Everything that I'm showing you here can be done in either Objective-C or in Swift. So if I'm showing you that, don't think it's limited to just one of the language options. But to get back on topic, when we're talking about the Cloudant database, you can access everything from the database from the client side. And as I mentioned, you can serialize those as generic objects, which is essentially NS Dictionary, which the best way to think of that, if you're not familiar with Objective-C and what NS Dictionary is, it's basically just like a JSON object. So you can serialize them as generic objects, or you can have it serialized to strongly typed objects. And with strongly typed objects, when you're using them within your application, you're going to get that compile time error checking to make sure that you're using the object correctly. If you're using a generic object, you don't get that compile time error checking. But you can use it in either scenario, or if you want to hook that into, you can access it from your Node.js server. So if you want to have some kind of server-side processing and have that manipulate the data or calculate or do something else or tie into some other workflow and then expose it up to your mobile application, you have the ability to do that. Or you can hit the Cloudant database directly from the REST-based API. So if you wanted to tie into it from another system, or if you want to hit it directly with this. If you're building the mobile app, I would strongly recommend that you actually use the Cloudant iOS SDK, not necessarily hit it as a RESTful service, but if you want to just hit it as a RESTful service, you would be able to do that. Now, the data, so the app that we are looking at here, all the data that's showing up right here, this is actually coming from the Cloudant database. And I'll jump over to the Cloudant dashboard. We'll open this new tab. And wait on the network. I need the Jeopardy song to play anytime I'm waiting for the network to respond, just because I feel like it would make it more entertaining than sitting here waiting. Really? Where is it? Okay, I don't know if I'm reusing. Maybe I'm reusing Windows. Let's jump back to our dashboard. And if it doesn't come up this time, well, there is a database there, I promise. And all I was going to show you was just the web-based interface if you wanted to see what was actually in the database. So we'll go to Cloudant dashboard, and we'll launch. OK. I have no idea why that's not actually loading. So let's jump back over here. The database does exist, I promise. The data I'm showing you right there. I'll jump back to in here within the app where I have claims table view. And in the app, so right here on the right-hand side, I've got my claims list. This is just a UI table. And I'm displaying data that's been pulled back from the Cloudant database. So in Xcode, in Objective-C, it's very, very simple to get data back from the Cloudant database. So right here, the first thing that we see is I'm accessing a remote store. My database is called InsuranceDB. Do I need to make that bigger? Can you guys see that? OK. So the first thing I'm doing is accessing the data manager shared instance, remote store InsuranceDB. This is just accessing that database I created called InsuranceDB. You can create a local store, which is going to have the local data. And you can use what's called replication, so that any changes that you make in the local store and the remote store, they can have replication and synchronize so that you can have offline state for your applications. In this code, I'm just showing it very, very simply. I'm not showing the local store, but you do have the option to have local store as part of this API. So I've got my database. I'm next creating an index. So on the store, create index with name. We're going to call it customer name index. The field that we're going to make that index on is customer name. Now, I'm showing this again, the process to make it very simple. You don't have to create an index every time you want to read data. I just have this kind of the flow so I can talk through it. You would really only have to create this index once. Once I've created the index, now I want to search my data store. I've only got like 10 records in there, but I wanted to search it. And with that, we're going to perform a query. Now, the query, we're going to do this by creating an NS predicate, where we're just going to say, customer name is greater than the empty string. So it's going to pull back all the customers for me. Very, very simple. So we're going to perform query. And then on the completion handler, we're going to get back an array of results. In this case, I'm treating it as that generic NS object, or sorry, NS dictionary object. So it's going to be, it's not a strongly typed object. And I'm just going to loop over them. I'm going to stick them into an array. So right here, add object. So actually, for when you access them this way, you get a reference to a revision of an object. So because the NoSQL database, the way that it works is it stores historical revisions of objects. So you can see changes over time if you wanted to. I'm just going to get the current revision. I'm going to just add that to an array. And then right here, I'm setting claims data equal to my array. So I've looped over, populated this array. And then we're going to jump back to our main thread right here. And I'm going to say reload data. So yes, when we're Objective-C, we're doing server versus request to the server versus updating the UI. Yes, you have to be thread safe. So you have to think about whether you're in a background thread or the main thread. But then when we reload data, this is just a method on UI table view, and then that's going to put the data into the application. So if I kill it here, let's see, there's actually a tiny delay. Once I hit sign in, there's a delay, then the data loads. So that's what's happening is the UI is displayed, makes a request off the Cloudant server, that pulls it, we get the data here, and then we're refreshing the table. Pretty straightforward, pretty simple. We're accessing data from the database without having to do a single line of server-side processing. We're doing it with this information here, and that's what? 20 lines of code plus comments in order to be able to pull data from the backend NoSQL database. So with this, once you set this up, it's going to give you the instructions on everything that you need to do to pull this into your application. If you did the Cocoapods install, then you already have everything inside of your app. Once you are in here, you can see the databases that you have. You can drill into detail. We can see what the objects are in indexes. Actually, I want to jump into monitoring. We can see how many database operations have happened over whatever period. Again, I think I'm showing the last 30 days, so you can see per day how many database operations have been happening. If you have a much bigger system with a much heavier load, you'd be able to see spikes and a lot more additional detail. You can also see storage, which this is rounding right here because I'm probably at more like 0.02 megabytes of data, but it's rounding down. You can see I'm not using much storage at all, but you can get a snapshot of the information about how much data your cloud-based database is using. And let's see, whoops. Configuration, I don't think we need to jump into that in detail right now. Okay, so now I'm going to jump back to the dashboard. Come on. And the last thing I want to show you about the mobile-first platform on Bluemix is push notifications. So it's a very, very simple API for push notifications. Now, if you're doing push notifications, whether it's native, whether you're doing hybrid, whether you're doing iOS, whether you're doing Android, whatever platform you're doing, you still have to use the push notification messaging service from the platform. So Apple still uses APNS, which is Apple Push Notification Service. On Android, it still uses GCM, which is Google Cloud Messaging. You still have to provision your app ID the same way that you would if you were just if you weren't using mobile first platform. What mobile first platform gives you is the ability to very easily manage the notifications, so manage subscribing to notifications, of sending notifications, and also a RESTful API. So if at other points within your app you want to send notifications to multiple platforms, something like that, you can call into our API. So right now, I just want to show you very quickly how easy it is to send a push notification. And again, I mentioned this can be done manually or from a RESTful API. So if you want to tie into a bigger workflow and have analytics driving which notifications are going out to which devices on whatever they're subscribed to, you can tie into all those workflows. But if you just want to send a message to a particular device or to a tag of devices, where I said tags earlier allow you to send push notifications to groups of devices based upon their subscriptions, we can do that through here. I'm just going to send a notification to all registered mobile devices. We're going to say message text, this is a test. And let's go ahead, I'll close the app here and see if I can switch through these very quickly. We'll hit next, we'll hit send, we'll come here, and assuming we still have good network, come on, you can do it. There we go. We've now got our push notification. The latency, I'm going to say, is the network. So once you have the notification, you can use that to drive engagement within your apps. In iOS 8, Apple introduced silent notifications, also interactive notifications. So if you want to have the user be able to respond to certain actions and invoke a different process within your app based upon just interacting with a push notification, we can do that. So I'm going to again send one more notification. I'm going to give this a category as actionable, and the category is just a string. You can make it be whatever you want. Actionable. We're going to hit next. We're going to hit send. I'm going to switch over quickly. We're going to Okay, we've got our notification again. You can see it at the top. If I pull down here, you can see we've now got accept and decline buttons. And if I accept or decline, that's going to jump back into my app. It's going to invoke a specific function based upon whatever action I selected. And this is all configurable. So if I jump back into app delegate, right here, I'm setting up whatever my user notification actions might be. So I've got accept, I've got decline. I'm setting my categories actionable. This is all stuff that you would do if you're doing notifications on iOS anyway. The difference is in here. So here's my application did register for notification with device token. That's from Apple's platform. But once I register for notifications, the app knows I've registered for notifications. That's where we're going to use IMF push client, and we're going to register our device with the mobile first platform so that mobile first can take over managing all of our notifications. So you don't have to build the services for managing notifications yourself. We basically just get the shared instance. In this case, I'm setting the environment as sandbox, so you can have your sandbox push notification environment for development, then your production one for once you actually go into production. Registered device, and then we're subscribing to tags. In this case, I've subscribed to 2 tags, beer and wine. Every device that I have that's subscribed to beer and wine would receive notifications that I'm sending to each one of those tags. And again, I'm showing this for iOS. And the reason I chose iOS 8 is because I wanted to use those interactive notifications. But if I was using the non-iOS 8 beta, I could use a similar API that's almost identical to this and do multi-platform push notifications with it. And let me jump back over here. In a nutshell, oh yeah, and the last thing I want to show you is, again, I mentioned having insight into what your app is doing. We can see analytics based upon push notifications. So we could see earlier what devices are using the app, what services are being consumed, what's the load on the system, how much data is we reporting automatically in the database. We also get that at the push notification level. Because I'm using Sandbox and I'm not using production right now, it's limited on the data that it's actually going to show me. But I can see how many devices have gone, or how many push notifications have gone through the app, how many devices are subscribed. Right now it's blank because I'm not in production. But you'd be able to see a snapshot of the performance, like what's the load, like how much usage is this notification system actually getting. So a lot of that has been mobile first on Bluemix, the cloud services platform. Very quickly, I want to switch gears because I know I have an hour and 15 minutes for this. I'm targeting an hour, so we've got like 13 minutes left. So if you guys have questions, I'd like to be able to answer them. If not, I think I'm standing in between you guys and happy hour, so I don't want to be in that position. Now, let me close this one. Let's jump over. We'll stop this. I have an almost identical application that's now using the Mobile First Platform Foundation server that's running on my local machine right here. So I come in here, you're not going to see anything different. However, this was developed using the local server. So this would be for an on-premise installation. The application server is basically could be deployed to a J2E server, WebSphere, Liberty server, something like that. Some people deploy it on Tomcat, it all depends. When you're building your app, you have 2 ways of building the application. How many people love Eclipse? Okay, a couple hands. How many people hate Eclipse? Okay, I expected this. It could be very polarizing. There's 2 SDKs. There's a command line SDK, so we've got our CLI, which I'm about to show you here, or we have the Mobile First Studio, which is based upon Eclipse. If you want to use Eclipse, you can do that. If you don't want to use Eclipse, you don't have to use Eclipse. And I can show you both of them, but since I'm talking more about native iOS right now, I'm not going to focus on Eclipse. In either case, we have a command line API, so I'm just going to run MFP, and let me zoom in on here. If you want to create a new project, we just have to run, and here's sample usage. So if you're just running MFP, we'll show you all the steps you need to actually create a new mobile first application. MFP create project and give it a name, my project, whatever it might be. That doesn't matter. It's going to create the project for you. Go into that directory, and then we can say MFP add API. When you're adding an API, you can add iOS, you can add Android, you can add hybrid, you can add Windows Phone. It all depends upon which platforms you want to target. But once you do that, it's going to give you the platform-specific hooks that you need to tie into the mobile-first server. If you want to, pardon me, if you want to expose data, we create what's called data adapters. And you can add an adapter just by running mfp add adapter, and then you specify the adapter type. It can be a SQL adapter, so it's going to be querying a relational database. It can be an HTTP adapter, which could mean, let's say you want to consume a SOAP-based web service, get the data, and then take that verbose SOAP output and put it down into something that's much more consumable and turn it into a JSON object. We can do that for you very easily. Or if you want to, let's say, consume an RSS feed and do screen scraping and turn that into a different object that can be pulled in your app, we can do that very easily also. I'll show you different types of those very quickly. Then once we go in there, we're in our project. We just run mfp build, mfp deploy. That's going to deploy it to our server instance. Once we are deployed on a server, right here, you can see the Mobile First Platform Operations Console. You can see right here I've got my app. It's called Insurance Dashboard iOS. And I've got multiple versions here. And I've got version 1.1, 1.2, 1.3. This is where I was saying we can control which versions of the application are live out in the wild. So right now I've got my app version 1.3. Let's say if I want to display a message to everyone using version 1.3, and I say, warning, your app, if I can type correctly, app will be deprecated tomorrow. Sure, tomorrow. Why not? We save it. Let's jump back over to the app. I'm going to close this. I'm going to come back in. And we've now got our message right there saying, service notification, warning, your app will be deprecated tomorrow. That message is only going to go to the version that I've specified. So if I've got version 1.1, 1.2, 1.3, and I only want it to go to 1.2, then we can set up, it'll only go to 1.2. It's still going to work as expected. The app is not going to cease to function, but it's going to display a message saying, hey, this is a message. And that's based upon, how we've configured it. Now let me jump back over here and let's say access disabled. And we're going to say, we'll add a message update now. And we'll put the update URL. And we've got our app running again. Let me close it. We'll come back in. And you can see it says application disabled, update now. When I do this, actually, let me go ahead and dismiss this. We'll close it. We'll kill the app. And we'll start it again. Oh, wait a minute. It's probably still connected to our debugger. Yes, let me stop that. OK, now the application restarted, and you can see it says update now. Because we've set access disabled on the mobile first server, that cuts off access to the app from doing anything. So if it tries to communicate with the backend server, all services, all data, everything going to that version of the application is going to be cut off. So this can be useful for multiple things. One, if you want to force compliance and force people to upgrade to a new version, you can use this approach to force people to upgrade to that version. Or let's say you have multiple versions of the app that are out in the wild, and all of a sudden your security researchers have discovered that there's a severe security bug in version 1.1 of your application. You can go in here with a click, you saw how simple it was. You enter a message, you hit save, and you can lock down access to that and cut it off completely, thus eliminating that security hole. So it's part compliance, part security, allows you to manage which versions of the app are live out in the wild. So if I hit upgrade, it's going to take me to whatever URL I put in for the upgrade server URL, and that could point to the app store. It could point to an internal app store, so if you have an enterprise app store. And I didn't mention earlier, part of Mobile First Platform is that if you have that on-premise solution, it has a private app store in it also, so that if you need that, that private app store, you get it out of the box. And one other thing, while I'm on the topic of mobile-first platform and the App Store and everything, is that if you're thinking about this, if you're looking at this, say, some of these are nice features, but I only have one app, and I can do some of that myself. I'm like, yeah, you do have a point. A lot of it you can do yourself. But if you're in an enterprise and you have one app, okay, most enterprises have more than one app. You have 2 apps, you have 5 apps, you have 10 apps. The advantage of the platform really starts to shine once you get in that multiple number of application, because all that infrastructure, all the boilerplate, all the steps that you need to set up your applications, it eliminates the overhead of setting all that up for you. You basically just pull in the platform, set it up, and it's there. You can take advantage of it. So I keep trying to click on it there. So we'll hit close here. I'll hit sign in, because my sign in is really just dummy. It's not doing an authentication. It's just going in. And you can see that when it made my request to the server to get data, I got the same message. And it will not serve any data if the application has been disabled. So I just wanted to show you that to prove that we've now cut off all data coming from the server just by setting that one application management task. So let me jump over here. And so again, now I'm talking about that on-premise installation. So we can also see which devices have been consuming the application. So we can see, in this case, jumping over here, we can see that I've had multiple iPad simulators with different operating system variants, multiple iPads, different operating system variants. We can see all these have connected to the server and been consuming data. If you have 100,000 devices, you could list them here, you could search, you could report on all of them, you can see everything that's been accessing your system. We could see, if I had push notifications set up, I don't have push notifications set up on my local server, we'd be able to see it here. We'd be able to see which platforms, what kind of data, everything that's involved with that. I mentioned earlier so there's a remote logging. We can set up log profiles. And in here, I mentioned this scenario earlier where I would say, if I want to collect all logs for my application, so we're going to say a particular application, we're going to say I only want them for version 1.1, I only want them on iOS, I only want them on the iPad, and I only want them on iOS 8.1, and I only want to catch them at warning level or greater, then I could set up a log profile, I hit submit, that creates the log profile, and then we're capturing information for any device that's consuming our services that fits that, that scope, depending upon what I've selected. Okay, just a couple more minutes, I promise. From there, let me go ahead and jump over into our operational analytics. And so this is our analytics dashboard, which is very, very similar to the information that I showed you for the mobile-first platform for Bluemix. But in this case, it's going to be what's captured on my local machine. And in this case, it's showing data for the last 24 hours. Again, there's a limited amount of data here because it's only from what's on my machine. But if you're in production, you'd have a lot more data than this. So we can see how many sessions are there. If you have multiple apps, you could see what's the distribution. These are pie charts, not just circles. You can see the distribution, which apps are being used, which environments were being used, whether it's iOS, whether it's Android, whether it's something else. Which data adapters are being used. So you could see, I haven't shown you data adapters either. So you can see that. You can see a lot of the same operational analytics that I showed you earlier, including devices, network adapters, network consumption. So you can see here, we can see I've got one app, but it's consuming data from multiple procedures, multiple adapters. I could jump in to see details in the network summary, so I can see, let me expand that to the last 14 days. I can see average response time, or I could jump into information about specific, the average across this time period for what's the response time for different services. I can see the average response size, so I can see procedure bytes sent. And so you can get these operational analytics to have insight into what your application is doing, and you get all of this out of the box without having to write any additional code. So there's devices, there's adapters, you can see servers, you can see activities. We can also, again, do the remote collection of logs, so you can see all the log values and get all the logs for a particular set of devices. But the last thing I want to show you for the mobile-first platform foundation server is data adapters. And data adapters, I mentioned them briefly earlier. You can create an adapter, whether it's an HTTP adapter, a SQL adapter, whatever it might be. You write them in JavaScript. Even though it's being executed on a Java server, you're writing these in JavaScript. They run in the Rhino JavaScript engine. And it makes it very, very easy for anyone to expose data from, whether it's a legacy system, whether it's a RESTful API, whatever it might be, and expose that into your application. And then also, because they're being consumed through the platform foundation server, you have that ability to control access to the services, and you also get the operational analytics without any action on your part. So here I have my data adapter, and when you create an adapter, there's either 2 or 3 files that get associated with it. There's an XML file, which is kind of like the definition of what gets exposed publicly, and then there's the actual implementation, which is a JavaScript file. So in here, I've created an HTTP adapter, and you can see that I'm going to hit this domain, which is basically, that's my Cloudant database. I'm exposing it through here so that I have that operational analytics, but I could call it directly if I wanted to. Yeah.
Sorry to interrupt, but is this the old way? Like, is the Node.js the direction that things are heading? The Node.js option you were showing? You were showing a Node.js option before. Is that the new approach to this?
So the Node.js, the question was, is Node.js the new approach, like the way that things are heading? Node.js is the option that's available if you're doing it through the cloud services right now. If you're doing the on-prem installation, it's going to be this implementation, so it's going to be based upon this server. And if you're familiar or if you've heard of Worklight in the past, this is how Worklight worked. Worklight is now Mobile First Platform. It was just rebranded not even 3 months ago. So once you have the configuration, you've defined what's being exposed, you've got your adapter that's been deployed, you basically just create JavaScript functions. And in this case, I'm setting up right here. It's calling wl.server.invoke.http. This is going to say it's going to call the HTTP service that I've configured through that configuration file and pass in my input, which my input is this object right here, where I'm going to say it's going to be an HTTP post. We're going to go to the path insurancedb/_find, which is part of the RESTful API for Cloudant. The prefix for the actual server, the domain name for the server that we're going to use was in the XML file. So if you want to easily configure that between multiple environments, you configure it in the XML. And then we're going to say pass in any parameters in the body. So in the body of the content type's application JSON, and it's going to be based upon this query that I've created right here. It's, if you have questions about that, see me afterwards. I don't want to take up too much time with it. But basically, it's writing JavaScript. It's really simple. It's going to return a JSON object back. If you wanted to access data from a SQL database, it's really simple. Right here is a sample. We've got a SQL query where it's wl.server.createSQL statement. We've got our select statement. And then the procedure 1 is actually the procedure that you're going to invoke from your application. And it's just going to call invoke SQL query. It's going to pass in the prepared statement and any parameters. That's going to return a JSON object to you that contains all the data that was returned from that query. So it's very, very, very simple to start exposing data within your application. So if you have, whether it's an Oracle or whether it's a DB2 or whether it's a MySQL database, we can hook into those very easily, expose those within your apps, and start bringing that information live into your app environment. So with that, I know I'm going a couple minutes past where I actually wanted to go. I want to jump back over here. Where'd we go? We'll jump back to my first slide. And in particular, this is my Twitter handle. My name's Andy Trice. I am a mobile first developer advocate, so I'm here for you guys. I'm here to answer your questions. If you have more questions, find me afterwards or hit me on Twitter. Or find me around here. If you want to make fun of me, hit me on Twitter. If you want to heckle me, you can do it right now. But I just want to say thank you.